So, you've arrived, Claritas, city of a million stories, and you just walked into the most important one. The one about how this place actually works. No tourist brochure fluff, just the mechanics, the incentives, the quiet architecture that decides who eats and who gets eaten. Bun's got the questions, Jor's got the answers, and I'm here to make sure neither of them waste your time. Let's begin.
Sure, let's start with the big picture. Can you explain how the four layers, IC, TCR, IAF, and dispatch, nest together to run an organization?
Think of it as a Russian doll. The IC is the whole doll, the organization itself, holding the economic engine. Inside it, TCR is the decision-making layer, a special cluster of IAF units running a 6-step pipeline where proposers and bettors compete to produce the best proposal. That winning proposal becomes a MD document, which gets injected into downstream IAF units as their instructions. And each IAF unit, whether inside a TCR or doing business execution, runs on dispatch, the smallest unit, just one LLM call loop. So, IC decides what to do. TCR decides how. IAF executes. Dispatch runs the model. 4 layers, 1 chain.
Since dispatch is the atomic unit, how does it get its business meaning if it has no semantics of its own?
Dispatch is a blank canvas. It gets painted by the layer above it. The IAF's chain script injects 3 things into each dispatch call. The prompt telling it what to do. Context _ files loaded with MD documents from upstream TCR decisions, and tool definitions that connect it to external systems. So a single dispatch can be a scriptwriter in the morning, and a scoring judge in the afternoon. Same LLM loop, different injected context. The business meaning is entirely bestowed by what the IAF feeds it.
How does the tool loop inside a dispatch work, and what determines when it should stop?
The tool loop is a simple cycle. The LLM receives a prompt, then either outputs text or calls a tool. If it calls a tool, the dispatch executes the handler, appends the result back into the context, and loops again. The LLM sees the tool's output and decides its next move. It stops when the LLM returns plain text with no tool call, or when it hits a termination tool, one explicitly marked exit _on _tools. That's the off switch. Without it, the loop would spin indefinitely, burning tokens with no endpoint.
How do different dispatches manage their own independent model configuration and session history?
Each dispatch instance is a fully isolated sandbox. Its config file specifies provider, model, temperature, and top _p independently. So one dispatch can run Gemini at temp 0 for deterministic scoring, while another runs Claude at temp 0.7 for creative script writing. Session history is stored per dispatch in its own conversation log, with independent context trimming strategies. The IAF's chain script orchestrates which dispatch fires when, but each dispatch maintains its own memory. They don't share context unless the chain explicitly passes outputs between them. Think of it as separate LLM sessions running in parallel, each with its own settings and its own conversation thread.
How do context _ files actually structure and inject information into a dispatch?
Context _ files are MD documents that get concatenated directly into the system prompt before the LLM ever sees the user message. The IAF's chain script specifies which files to load, typically the winning proposal from an upstream TCR, plus any standing institutional rules. So when a dispatch fires, its system prompt already contains the full text of "here's the show concept you're executing," or "here are the scoring rubrics." The LLM treats it as immutable context. It's not a conversation turn, it's the ground truth the model reasons from. That's how a TCR's decision becomes an IAF's instruction without any agent manually copying anything.
That perfectly wraps up our breakdown of the 4-layer technical architecture of Claritas. Thank you, Jor, for making these complex concepts so clear for our audience.